Hey guys, so we're going to do more solving systems equations today, but before we get into it, I want to kind of pictorially show you what's going to be happening today. So, in the past, for the past 2 days, you guys have been solving systems of equations, two lines. So, here's one line, and then here's another line. And we would find the intersection point of these two lines. And for this one, it's 0.375 and 1.75. And we we would use the elimination method to find this exact intersection point. Well, that's not the only way that lines can interact with each other. All right, they can interact with each other in two different other ways. We can have a line here, which if you guys notice is the actual line of the equation for the number 2. And here's the second line. All right. And what are these two lines doing? How are they interacting? Well, they're parallel. Okay. Which means that they're never going to touch, which means there won't be a solution. And we have to see what that looks like. We are going to see what that looks like in a little bit later on, algebraically. All right. So this is another way that lines can interact with each other. So far we have intersecting lines. Okay, we can have intersecting lines, or we can have parallel lines. Okay, or last but least, we can have, here's one line, and then here is another line on top of it. Notice that it turned blue. Well, that's because I turned on this blue equation line right here. These lines here are called overlapping lines. Okay, these overlapping lines means that I have multiple solutions. I've got a solution here, 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 a solution here. They're overlapping, so I have infinitely many solutions. And so we are also going to see what that looks like algebraically as well. So today we are going to learn how to determine whether the lines intersect. And you guys already know how to do that, or what it looks like when they overlap, which will be new, and what it looks like algebraically when they are parallel. Okay, so here are the directions for what we're going to be doing today. It says solve each system by elimination, and then this is what's going to be important. Identify each system as either having intersecting lines, parallel lines, or overlapping lines. So the way that we can tell if we have intersecting lines, and I'm going to circle that, is if we go through all of our work and then we have something like x equals 7, we'll get an actual value, and then y equals, I'm just making this up guys, y equals 3. All right. When you get a value like this, that means that you have intersecting lines. Okay? Oh, sorry, lines. And then let's say we we want to see. Let's talk about parallel lines. So when we have parallel lines, you're going to end up with something that looks really, really wonky. You're going to have something that looks like 7 equals 0, or 0 equals 7, something like that. And so you're going to ask yourself, is this ever true? No, 7 is never equal to 0. 7 is never equal to 0. 0 is never equal to 7. So when you get an untrue statement like this, that means it's never true, which means it'll never intersect, which means you have parallel lines. So if it's never true, it never intersects, and I'm going to abbreviate now. So that means we have parallel lines. Okay, and then last but least, we're going to talk about overlapping lines. So when we have overlapping lines, we're going to have something that will look like this. It'll say either 0 equals 0, or 1 equals 1, or 2 equals 2. And these statements here, the 0 equals 0, 1 equals 1, 2 equals 2, are these statements always true? And the answer is yes, because 1 is always going to be equal to 1. So if it's always true, that means there's always a solution. It's always a solution, which means there's infinitely many solutions. So that means that we have overlapping lines. Lap. Sorry, guys. Lapping lines. Sorry that it's kind of, I'm running out of room here. So when you get, just to recap super fast, when you find actual values for x and y, that means you have intersecting lines. When you get an untrue statement like 7 equals 0, or 1 equals 2, or 2 equals 3, whatever it is, that means it's never true. They never intersect. So that means we have parallel lines. And then when you have a true statement, something that's always true, okay? 0 equals 0, 1 equals 1, 2 equals 2, 100 equals 100, whatever it may be. It's always true, which means there's always a solution, so that means there's overlapping lines. And then just to point out, there will be, there will be an absence of variables, because we're going to end up eliminating them all. There's an absence of variables. I know it looks kind of weird, but there will be an absence of variables. And here there will be variables, which means they're intersecting lines. Okay, so then let's go ahead and take a look at the next video, video 7.